All right, my friends, are you ready for the final steps of this implementation? First, we're going to visualize the training set results, and second, we will visualize the test set results. So let's do this. Let's start by creating a new code cell, and there we go. Now we just want to plot on a nice graphic the real salaries compared to the predicted salaries. So basically, we're going to have a 2D plot with the x-axis being the numbers of years of experience, from 1 to 10, and the y-axis being the salaries, in the range of salaries given in this data set. And so we will plot in red points the real salaries and in a blue straight line the predicted salaries, okay? And we will do that both for the predictions in the training set and the predictions in the test set. Are you ready? Let's do this. So I didn't expect you to implement this yourself before, doing it together, because there are actually a lot of new tools that we're going to use here, and especially Matplotlib. You remember this library, Matplotlib, allows us to plot some nice graphics, including the ones we're about to plot. So we're going to first call Matplotlib. As a reminder, it has the shortcut PLT. Actually, what we're going to call is exactly the PyPlot module from the Matplotlib library, and this is what is having the PLT shortcut. So there we go. Let's start by calling PyPlot PLT from Matplotlib. And then we're going to call a specific function from this module, which is called scatter. And scatter will allow us to put the red points, corresponding to the real salaries in the 2D plot. Okay, so naturally what we have to input here are the coordinates of these red points representing the real salaries. And these coordinates are nothing else than X train and Y train, right? Because remember, the X-axis will be the numbers of years of experience. That's what is contained in X train. And the Y-axis will be the salaries, and that is what is contained in Y train. So here, in scatter, here we just have to input the coordinates. First, X train for the numbers of years of experience. There you go. And then Y train for the salaries. Okay. And then we can add another argument, which is color, and which will allow us to choose a color of these points. And as we said, we're going to choose red. Perfect. And that's the first thing. This will just plot the red points corresponding to the real salaries in a 2D plot. Then, next step, or next sub-step, is to plot the regression line. So remember from the intuition lectures, the regression line is the line of the predictions coming as close as possible to the real results, to the real salaries. And therefore, and that's why it is called a linear regression, the predictions, the points corresponding to the predicted salaries will follow a straight line, right? As in a linear function. And therefore here we're not going to use the scatter method, we're going to use the plot method, because that's what we use to plot the curve of a function. And since our function is linear, it will actually be a straight line. All right, so there we go. Let's call first the PLT module, PyPlot. Then from this module, we're going to call the plot function. There you go. And in this function, well, same as in the scatter function, we have to input the coordinates of the point or line nodes corresponding to the predictions. Actually, you have all the descriptions of the diverse tools we use in Google Colab. That's one of the many beauties of Google Colab. And so you can have a look at more information here if you'd like, but that's very intuitive. We just need to enter, once again, the coordinate of the predicted salaries, and this will just plot the line following these predicted points, okay? So let's do this. According to you, what is the first coordinate of these predicted salaries? Well, that's of course X train. Why is that? It's because right now we're visualizing the result of the training set. Okay, so these corresponds to the numbers of years of experience of the employees in the training set. That's the X coordinates. Okay, now we're going to input the Y coordinates. And according to you, which ones are these? Well, it's something we haven't created yet. We created actually the YPred variable containing the predicted salaries of the test set, but we haven't created a vector containing the predicted salaries of the training set. And that's totally fine. What we'll actually enter here as the Y coordinate of this plot we're about to make are going to be exactly the predicted salaries of the training set. And to get them, I'm going to copy this and paste that right here. But instead of inputting here xtest, I'm going to input actually xtrain, because calling the predict method on xtrain, meaning on the numbers of years of experience of the employees in the training set, will get me exactly the predicted salaries of the training set. All right, just as before with predict X test. So xtrain, yes, and then just as before, we're going to choose a color, which this time will be blue, right? So that we can clearly see the difference between the real salaries and the predicted salaries. Okay, so this will plot the regression line. Now, next step, what can we do? And that's just for the sake of the form. I want to train you how to build a nice chart or a nice graphic with Python. So here we're going to add a title, and to do this, we have to call the title function, and inside, in the parentheses, we just have to input in quotes, well, the title we want for our graph. And so let's say salary versus experience. Okay, you can choose any other title if you prefer another one. So salary versus experience, and then we're going to specify the training set, because indeed, then we'll do the same for the test set. Okay, salary versus numbers of years of experience in the training set, right? This is a very precise title. Now, we're just going to add a label to the x-axis and to the y-axis, and for this we have to use the xLabel function, into which we have to input, well, the label we want to display on the x-axis, and we're going to choose, in quote of course, years of experience. All right, good. Now we're going to copy this because we're going to do the same for the y-axis, and the name of the function for this is ylabel. That's why I just did a copy paste. And for the ylabel, well, we will choose to display salary. Okay, salary. And finally, in order to show the graphic, well, we just had to finish here with plt.show, the show function, and this will display the graphic in the output. All right, so good. Now we're going to do the same for the test set results. So I'm just going to copy everything here and paste that in a new code cell right here. And so now we're going to do the right replacements in this code in order to visualize this time not the training set results, but the test set results. And so obviously the first thing we need to replace here are the coordinates of the real observations, because these are the coordinates of the employees in the training set, and we want the coordinates of the employees of the test set. Therefore, here we have to replace obviously xtrain by xtest and then ytrain by ytest. Okay, so these are for the real observations with the numbers of years of experience and the real salaries of the test set. And now, according to you, do we have to replace something here in PLT plot xtrain regressor.predict xtrain? According to you, do we have to replace xtrain by xtest and the same xtrain by xtest? Well, that's kind of a trick question, because remember that the regression line that we get is actually resulting from a unique equation, and therefore the predicted salaries of the test set will be on the same regression line as the predicted salaries of the training set. And that's why here we actually don't have to replace xtrain by xtest here and here, okay? You would actually get the exact same regression line whether you plot the coordinates of xtrain and the predicted salaries of the training set, or xtest and the predicted salaries of the test set. You can check, but that's because the regression line in a simple linear regression model results from a unique equation, and we therefore end up with the same regression line. Okay, so no need to replace anything here. And finally, we will just replace here training set by test set. And there you go. Now we're ready to visualize the training set results and the test set results. So let's first run the cells we haven't executed before. So remember, we executed up to the training. So now we have to execute this one to indeed get the vector ypred of the predicted salaries of the test set. So there we go. We now have ypred. And so now we're going to first execute this to visualize the training set result. And we're going to obtain now a nice 2D plot with indeed the real salaries in these red points here, and of course our beautiful regression line containing the predicted salaries. And we clearly see that this regression line was calculated so that it comes as close as possible to the real salaries. And of course, for each of the years of experience here, in order to get the predicted salary, you have to project the year of experience to this blue regression line. So for example, the predicted salary corresponding to 8 years of experience is about, $100,000 per year. Okay, so that's how it works. And so we can clearly see that our predicted salaries are very close to the real salaries, for most of them. But that's on the training set. Remember, that's important because our model was actually trained with these observations, with these years of experience and salaries. Now, what we would like to observe is if we have the same result, the same closeness of the regression line to the real salaries in the test set with which the model wasn't trained. We want to evaluate it on new observations. And that's exactly what this new graphic will tell us, because now we're about to plot, this time, the real salaries of the test set and the predicted salaries of the same test set. So there we go. Let's run the cell and let's see if we're still close to the real salaries even for new observations. And yes, absolutely, our predicted salaries, which are, of course, on the blue line once again, are very close indeed to the real salaries. So our model, our simple linear regression model, was able to do a wonderful job at predicting new observations. So congratulations, that's very exciting. You built a very successful first machine learning model. However, just remember that the reason why we get such a good regression line here is simply because there was a linear relationship in the dataset between the features and the dependent variable of the dataset. In other words, we had a perfectly linear dataset. In other words, we had a dataset with linear correlations. And what I want to make sure you understand is that these beautiful results won't happen for any dataset, because of course you'll get to work on datasets with nonlinear relationships, and for these datasets you will need a nonlinear model. And that's exactly why in this part 2 regression we will also study some nonlinear models, which you will see will be polynomial regression or SVR, which will allow you to get amazing results for datasets having nonlinear relationships. But for this dataset, we clearly had linear relationships, and that's why a linear regression model was perfectly fine, but I just wanted to highlight this. Okay? So congratulations once again. I hope you're very happy and excited to have built your very first machine learning model. Now we're going to increase the difficulty a bit, because in the next section we will build a multiple linear regression model, meaning that instead of having one feature, only one independent variable, we will have several of them. And that's exactly the difference between simple linear regression and multiple linear regression. Simple linear regression is when you have only one feature, and multiple linear regression is when you have several features. So take a good break now, and as soon as you're back with your energy, let's implement our second machine learning model in the next practical activity after Kyril's intuition lecture. And until then, enjoy machine learning.